Welcome, ladies, gentlemen, and eldritch beings from the outer cosmos. I am Craken, and today we are talking about machine learning. More specifically, we are going to be using an architecture called long short-term memory, or LSTM. This is a type of neural network which has feedback connections to help analyze sequences of data. In more understandable terms, a regular good old feed-forward neural network looks at some data, processes it, and then throws it straight out the window and forgets about it when we give it the next instance of the data. This is useful when we want to find results independent of each other, say classifying pictures into dogs and cats. Whatever the previous picture was has no influence on the next picture whatsoever. However, here's where the fun comes, because we are introducing the spicy little feedback connection to make a neural network remember the last few answers it made. This can be used to generate sequential data such as text that hopefully will make sense. And as you might have guessed, today we are going to be using Reddit comments for this training process. More specifically, we are going to use comments from r/RoastMe, even though I started out with wanting to do something else, but we'll get to that in the video. I'm now going to go into some technical details. This is not a tutorial where I type out every line of code on screen, but I will explain what I do and link my GitHub repos in the description, so if you want to look over the project for yourself, you easily can. If you are just here to see the machine-generated rows themselves that I managed to generate, and don't care much about the explanation behind it, skip to the timestamp on screen. With all of that out the way, let's get dirty. So as I've said before, I started this project wanting to use comments from multiple subreddits. More specifically, I went on redditlist.com and got a list of the 50 most subscribed subreddits to use for this. Then I wrote a scraper script that would let me choose what to sort the comments by, how many posts and how many comments to go through it, and saved it all into one txt file. I've already written a script that does the same for individual posts from one subreddit, so it was really just a matter of changing it to loop through all the subreddits I wanted. I used prov, which stands for Python Reddit API Wrapper, a handy little utility to mess around with Reddit. If any of you are interested, every script I've written for this project is linked in the description. And if you drop me a comment, I might even do a video just on Pro and how to use it to extract data from Reddit. So we have our list set up, our scraper will loop through it and save everything to txt files, one subreddit per file. Great, let's just run it overnight and... Great! So the internet gave out at one point and shut the whole script down. Perks of having weak internet on top of a hill, I guess. Well, whatever, I just took out the subreddits that the scraping was complete for and restarted the script. It will take a couple of restarts, but I'll have them eventually. That was a lot worse than expected. Okay, so the main problem with my script is that as soon as the connection gives out for even a second, the whole thing shuts down. It's also really slow. I first thought that was because of my horrible internet, but I tested the script at my father's place where the internet is beefy as heck, and it seemed to be the same speed. So I'm assuming the bottleneck is on Reddit's side, which kind of makes sense, of course, because they probably don't want me to bombard their servers with too many requests. Well, either way, we have our juicy data now, so let's get cracking. I threw together a quick 5-minute script just to give me some details on the files, and oh boy do I have a lot of data. I have around 800 million characters in total, which is a lot. Great, so let's throw together the neural net. I started by loading all the files up and concatenating them together. So now we go ahead and make 2 dictionaries. We want all characters we use to have a specific number assigned to them, so we can encode the text as numbers. So we go through all the unique characters and assign each of them a number. Great, let's look at what that looks like. Wow, and I thought Reddit had a hate boner for emojis. There are also a ton of what look like Chinese characters in there. Interesting. Well, anyway, now we need to split our data up into instances that we can use to train our model. Basically, since we want our model to look at what it output previously and use it as an input for what it needs to output next, we'll split the data into 30 character long chunks, which we will call sentences. Then to each sentence we will assign the next character that comes after them in the text in a separate list. This is the output we want our network to give. You with me for now? Excellent. Okay, so let's run that and... that's a lot of sentences. Good. let's go ahead and numpy the hell out of them. In case you don't know, numpy is a very handy library for Python. Python itself is fairly slow since it's an interpreted language, not a compiled one. Now, this is fine for simple scripts, but when it comes to doing complex math on big chunks of data, that is a big problem. NumPy is our solution, which is implemented in C and is therefore a lot more efficient. So now that we are ready to rock and roll with our data, let's convert our sentences and characters into NumPy arrays. Now, remember all that calculating with the number of unique characters we did like 2 minutes ago? This is where that comes in. See, when passing characters as numbers into a neural network, we don't just want to assign each character a number. The problem with that is that characters are not a linear scale. Say we want the network to output a B, right? That would be a value of 2, let's say. So then, do you say that if it output a C, that's a better solution than a U or an S? No, of course not. They are all wrong. That kind of mentality is useful when we are trying to predict numbers, for example, which can move on a scale. So when we want to get 14 but get 12, we can definitely say that that's better than getting minus 47. However, characters are distinct output sets and unordered at that. This is, by the way, the difference between regression, when we have an infinite potential outputs, and classification, when our output is one of finite distinct categories. So how do we store our characters? Well, imagine a vector which has many dimensions as we have different letters. All of them have a value of 0 except for one which has a value of 1. We could also do true and false, of course, which is actually what we are going to do. This is called one-hot encoding. Why do we use it? Well, we have a categorical data in our example, which we can't really work with in this case. We really need to use numbers. Now, as I've explained, of course, we don't really have a defined order between letters the way we do between numbers. So mapping them over one-to-one would mean our model could assume a natural order between our characters, which would lead to all kinds of weirdness. So instead, we one-hot encode it. Got it? Great. If not, please type in the comments, Papa Craken, make beginner machine learning video, please. Or Google it or something, I don't know. Anyway, let's enumerate the sentences and the cars to set the needed zeros over to ones and run it. Oh, sweet mother of Nyarlathotep, what is going on here? Okay, that there is 47.5 tabibytes, which is a bit more than 52 terabytes or 52,000 gigabytes, which I just tried to load into my 16 gigabytes of RAM. So yeah, that might be a problem. Why did our data size skyrocket like that? Well, remember when I said Reddit uses a lot of emojis? Apparently, we had like 6,500 different characters in UTF-8 encoding, which means we were storing a 6,500 dimensional vector for every character, every 800 million of them. Now, I'm not amazing at math, but even I can tell that 800 million times 6,500 equals really too much, so let's cut back on that. We are going to filter out our text into only letters of the English alphabet, space, new line, dot, question mark, exclamation mark, dash, and some other stuff that I decided to add later. Everything else we discard. Okay, that cut down on the number of our characters immensely, that's good. We still have around 250 gigabytes, which still doesn't fit into my RAM, and while that is way less than really too much, it is still too much. Not to be discouraged, I went to Google. I found a really good tutorial by a chap named Gilbert Tanner, link in the description, where he does something similar with the Adventures of Sherlock Holmes. I even changed my own code based on his example because he had some really elegant solutions in there. He also used around 500,000 characters and got decent results with a really low training time. The sentences didn't make a lot of sense compared to the original, but then again, Reddit comments are not really out there with classic literature in terms of complexity or making sense in general either, so I'm sure it will be fine. After a quick calculation, if around 800 million characters are about 250 gigs, then 500,000 would be around 0.16 gigs, assuming equal length of one-hot vectors, which is more than doable. Hell, I could even do a couple million characters easy. To test that out, I ran it on the around 3.5 million characters long announcements sample I had, and sure, it works great. Now it's up to what subreddit I want to use, because obviously now I want to make it more interesting than just taking one from the top 50 I already had scraped data from, and none of which I have opened probably ever, to be honest. So this is where my friend Remus had the great idea of using r/RoastMe, which is genius. On RoastMe, the comments are actually the main focus, so we are grabbing some good material, not just reactions to some article or opinion piece, as it happens, for example, on Unpopular Opinion. Second, my restriction on working only with top-level comments and not replies actually works in our favor. All the top-level comments here are insults. Well, all excluding the automatic messages by the bot, but those are such a small percentage they won't matter. Thirdly, it's just fun. Auto-generated roasts will be really fun to see. So next, I get to scraping data yet again. Also, I didn't end up using all that Reddit data sadly, which I also painfully gathered. However, I will put all of it on GitHub. If any of you feel like doing anything with it, you are welcome to do so. After quickly modifying the scraper script to put all comments into a single file and to skip the header lines, which add info about the posts themselves, I had my data. I used my txt checker script to look it over and I had roughly 21 million characters. That's still a ton, so I'll probably limit it down while training, just to go easier on my poor laptop. Of course, we'll still need to filter the characters out too, but that barely reduced the size last time, so I'm not expecting giant results now either. I thought it fit to try the script on all of my dataset anyway. It did the whole thinking and acting like I'm freezing for a couple of minutes act, of course, but it did work in the end. Great, so I still decided to restrict the program to only use the first 5 million characters, just as a proof of concept. Then I copy-pasted some helper functions I have stolen straight out of the Keras LSTM text generation notebook. That notebook helped me a lot with this project, so if you check it out, link in the description, you'll notice that most of my machine learning bits are taken from there. I am still new to machine learning, and this is the first time I did anything other than basic regression or classification tasks, so I feel no shame in looking up the work of some people who know a lot more than I do. After that, I defined the model. It is a sequential model with one LSTM layer, one dense layer, and a softmax activation layer. I set the learning rate to 0.01, set up the callback, and fit it on my dataset. Now, when I first saw that 18-minute training time pop up, I get a bit sad, but hey, you gotta do what you gotta do. So I decided to wait for it to train for an epoch, check out the results, and if it is working, I'll figure out a way to save the weights and the model after training is complete, and then run it overnight. But I was really eager to see some results already, so I thought a single epoch and then I'll have a look at the samples. Also, all those warnings that look really intimidating are TensorFlow complaining that it can't use my GPU. Since I have an AMD graphics card, setting it up would be a pain in the bottom side, and to be honest with you, I was getting a little impatient with this project by this point, so I didn't think it necessary. So after just one epoch of training, it looks like a promising to start. The network already figured out how I separated the comments by lines of dashes, and at a glance these look like sentences. Of course, most words don't really make sense, but some stuff seems to work. There are multiple comments starting with "you look like," for example, something to be expected, but it is really cool that it happens already after just one epoch. So I set up the system to save the model and the weights and fired it up to train overnight. So here we are after training for 60 epochs. Considering how small of a brain my boy here has, the results are not that bad, even though a lot of them don't make a ton of sense. For example, "you look like the person who are so shit" in the same time in the back to the title. "You look like a chance to see your face is a face of a baby." "You look like a person who assume you have a part of your face." "Your face is a divorced." Sorry, that I couldn't keep a straight face through that one. "You look like the shit." "The Tinder was a thing that looks like all the fucking shame." "You look like a dollar the girl that is a good will roast you." "She is the local gay." "He looks like the man." That might even be a compliment now that I think about it. "You look like you already roast the strong about you." "The only girl to be the dog needs a buddy." "I bet you have to work at a special." "Nut and finger and a job alone." Puberty. Okay, so as you can see, most of these insults don't make a lot of sense. However, this is about the result that I expected from the text generation network. It was relatively good. However, I am greedy and I want a better result. So let's save this dummy model away and beef up our network. I gave him a bigger brain and also introduced some dropout layers. However, this jumped the training time up a lot and I was already getting a bit tired of having my laptop run non-stop, which it has done for who knows how long now, so I decreased the training data size to just 1 million characters and the epoch count to 40. I still don't have a huge hopes for this version either, but hopefully it will do better. I hope at least. Okay, so after a night and another half day, here we are with the smarter version, who says, "You look like us strangers are to get a then a heart to roast you. You look like a base. You look like a hairline. You look like you probably put your finger nets. He looks like you're a convent of basement. Start your boyfriend. I would see you probably a than your hairline." That one is just so dumb it cracks me up. "You look like the internet." That's a pretty hard roast. "Your skin is supposed to compute that you don't want to be a working. I love you have our second really ass. You look like a shit. Your face looks like a dick is surgery. You look like a dick." Okay, now that's genuinely a correct insult, even if it's not a really creative one. "Just good luck getting into boy. You look like I never called you. When you don't joke." That could work, depending on the post title, I guess. "You look like his basement." So yeah, while these results may not look that impressive to you if you've never worked with any kind of machine learning project, they are actually pretty decent. The network managed to learn the structure of my commands, being separated by lines of dashes, and it also managed to pick up on some basic grammar structures, such as a lot of the insults starting with something like "you look like." So I am quite proud of this little AI, especially as it is my first attempt at messing with LSTMs. I have some ideas to improve the results. Most of them involve stealing, getting inspired by Andrei Karpathy's work on recurrent neural nets. But for right now, I'm a bit tired with this project, so that will not be my next video for sure. If you want to mess around with any of my project files, all relevant links are down in the description. Thank you for watching all the way through, and sorry for the horrible microphone quality. Stay safe till next time, my mortal friends. Cheers!